Hello students. Next problem 48th ones. Concave lens of glass has both surfaces the same radius of curvature. It is a concave lens. Careful with the lens. What kind of lens it is? It is a diverging lens. Same radius of curvature r. When it is immersed in a liquid of refractive index 1.75, it behaves as, first option, convergent lens means convex lens. Convergent lens means again convex lens of the different focal length 3.5 or 3 way to calculate, or diverging lens. Diverging lens means concave lens. It behaves like concave. Negative focal length means diverging. Positive focal length if we get means convergent. We have to take the help of the lens maker's formula for this. Initial lens is concave lens. For concave lens, light rays if they are coming parallel, they go away from the principal axis. Diverging rays. This is a mu glass. This is a mu air we have taken. Our refractive index of the air less than that of the lens material. Mu glass is 1.5. This is a mu glass equal to 1.5. This is approximately 1. But now we are taking the liquid. Lens is kept in the liquid. This is a mu liquid. E is equals to 1.75. This mu glass is 1.5. When surrounding medium refractive index is more than that of the glass or lens refractive index, material refractive index, then convex behaves as a concave, concave behaves as a convex. So it is already concave, air concave only, but air value is 1, surrounding medium is less than that 1.5. But here 1.75 more than that of the material, lens material means it behaves as a convex lens, means focal length negative becomes equal to positive. Lens maker's formula what you have is, F air is the focal length of the liquid by concave lens in the air. Then 1 by F air is equals to, it is a biconcave lens. F air is equals to 1 by F air, it is, careful with that, not F air. Mu g minus 1, the refractive symbol may be given n or mu, into 1 by R1 plus minus 1 by R2 is the basic formula of lens maker's formula. But radius of curvature, if you check up, the first radius of curvature is left side, means minus it becomes. Right side radius of curvature is R2, it is right side is positive. Distances. So this right side already it's as it is you leave, but left side becomes equal to minus. Minus R1 is equals to R2 equal to R. So R1 is negative. The result is that 1 by R means minus 1 by 2R. Minus I have taken here. That becomes equal to minus 1 by 2R is actually in air. Whatever is the value. This is not required for this problem actually. You have to take only this part. This is not required. This is only for explanation I have to given. You have to go for directly for this. So 1 by FL is equals to, in the liquid, this is in liquid. Concave lens, diverging lens in a liquid. 1 by F liquid is equals to, wherever mu g is divided with the surrounding medium. Here air is there, mu g by mu air is 1. Here liquid is there, mu liquid. Mu liquid is 1.75 given for us. Mu g by mu liquid minus 1 into 2 by R. This value is equals to 1.5 by mu liquid given as 1.75 minus 1 into 2 by R. Take the LCM of this, what you get the relation is 1.5 minus negative of minus 1.75. 1.5 can write 1.50 by 1.75 into 2 by R. This will become equal to 0.25 by 175. The result is, it is 1 by F liquids. But we want F liquids. Reverse of this here to take. The result becomes equal to 7 by 2 R. And this bracket portion becomes minus 0.25. Minus into minus is plus. The result is plus 7 by 2 R you will get. 7 by 2 means 3.5 R. Means plus is coming. Plus means it behaves as a convergent lens or converging lens. Behaves as a convex lens. Similarly, if you have taken the convex lens in that higher refractive index, then what happened to the formula? This becomes equal to 1 by R1. Right side is convex lens. For convex lens, light rays which are parallel will be converged towards the principal axis. Here they are diverged, but here after putting into the medium, instead of diverging here, it will be converged. When surrounding medium is refractive index more than the glass refractive index, but here in the air it is like this. If you take in this liquid you have taken of the higher refractive index, then parallel rays instead of going towards the center they will go like this. Means it behaves as a diverging lens. Then what is the formula for this convex lens we take is, convex lens that right side is R2, right side is R1. R1 is positive but R2 is minus. This becomes equal to minus, this is a plus. Minus into minus is plus. So you have to take compulsorily positive values plus 2 by R. Similar formula but plus 2 by R you have to take for the convex lens in the liquid if you have taken. So answer is plus 3.5 r. It behaves as a convergent lens of focal length equal to 3.5 r. Next one is a concept question. Solid transparent sphere has a small opaque dot at the center. Sphere, opaque one object is dot is there marking, or air bubble is there inside. It is a glass sphere, transparent glass sphere, so you can see inner parts. When observed from the outside, the apparent position is, when if we see from this side, where does that object appears to be? If you are seeing the slab, parallel surfaces, if you see from the air, any object inside appears to be shifted upwards. So this is a real depth, this is going to be apparent depth. Apparent depth is less than real depth. The object appears to be shifted, called as normal shift takes place. Even if you are observing through denser medium also, normal shift takes place and the distance appears to be increased. Here for the curved surface, if you taken the curved surface formula, you need to consider N2. If you take the curved surface like this is the object distance, image distance, radius of curvature is r, left side one is r1, right side is r2, but in this case it is the same values. Right side is r, left side radius, if you are taking this or part, no, minus r it becomes. Whatever you are seeing from this side only, the object is exactly at the center. When object is at center, the real depth will be equal to apparent depth. That point you need to remember. Because light rays coming from the object are along the radius only. When it is coming along the radius only, they don't get deviated. If the bubble or any object is inside the sphere, not at the center, some other place is there. In that case, light rays coming here, going like this, they go straight only. Come here, they go straight because the light rays are coming along the radius. Radius itself is normal to the surface. But if the object is here, then only this light ray is going straight without deviation. But any other light ray deviates, because this from center you take the normal, this is a normal supposed to be, and going the light ray from the object coming here will be deviated denser to red medium or deviating away. So it appears to be present here. That means this is a real depth. This is going to be the apparent depth. Apparent depth is less than real depth if you are observing from the radar medium. If the object is within the surface point, that is a pole, and center of curvature. If the object is outside center of curvature, then the image position will be different. You will get whatever. This apparent depth is less than real depth. In these cases, you will going to see. If the object is here, you check up the position, light ray path in what direction going, diverging ray you might be getting. Means negative virtual also is possible to see. So in these cases, if the object is at the radius of center of curvature only, then remember that real depth equal to apparent depth. There is no normal shift taking place. Next one is for 50th question. Silvering of the lens. 50th question. I didn't discuss the synopsis point for this, and this is only for, not for CET, it is only for JEE, and rarely can be asked for the NEET. Previously they used to ask for the CET also, but now I don't think they can ask for the CET. They will be asking for the NEET possibility, but most possibility is only for JEE. Point object is placed at a distance of 20 centimeters from the thin plano-convex lens. A point object, or just object you can take, is placed at 20 centimeters, a distance of 20 centimeters from thin plano-convex lens of focal length 1.5 centimeters. Thin plano-convex. If they don't mention thin also, we take it as a thin only unless specifically mentioned. Plano-convex lens of focal length of focal length 15 centimeters. The plane surface is silvered. Find the image is formed by the system is at where the image is formed silvered mirrors. We are taking the plano convex lens and focal length is 15 centimeters. The plane surface is silvered. Curved surface, two cases are in this. Plane surface can be silvered or curved surface can be silvered. Silvered mirrors. Plano convex lens. Silvered plano convex lens. First case, let us take a plane surface silvered. Surface silvered. So it is like this. And this surface is silvered. So it behaves like a mirror. This radius of curvature is R1. This radius of curvature is R2. It is like a plane mirror. Plane mirror radius of curvature is plane surface radius of curvature is equals to infinity. This radius of curvature is R1. That too, it is right side, means plus only you take it is equals to plus R we take R1 values. And when you keep the object left side, you are keeping the object left side, light ray is going from here and falls on the mirror and again reflects back. You can take any angle. Unless it falls normal on the second surface, it may retrace the path. Otherwise, the light rays will be going in any other angle, means they again reflect backwards, following the laws of reflection and again form here. So they may form the object, means this is going to be the image. This is going to be U, this is going to be V. V is left side only, means what? A negative. It behaves like a concave mirror. It behaves as concave mirror. Complete combination behaves as a concave mirror. Of focal length that we are going to check up. So what is the light ray? Light ray is passing through the lens two times. One time through this plano convex lens, second time for the mirror you have to take up. So here mirror is simply reflecting backwards. So resultant focal length becomes equal to 1 by, first let us take plano convex lens. 1 by f lens is equals to mu minus 1 or n minus 1 into 1 by r1 minus 1 by infinity. 1 by infinity is 0. So the result is 1 by fl is equals to mu minus 1. Mu is a reference to this material and 2 times it is going, but of course only for the lens, only single lens term you have taken, means by r it becomes. R is okay, let it be. This becomes equal to R. But here combination of lenses. Lens 2 times, mirror 1 time. Now silvered mirror. Silvered plano convex lens. 1 by f silvered lens is equals to 1 by f lens plus 1 by f mirror plus 1 by f lens. Combination of lenses if you are taken, then thin means contact you have to imagine without separation, then 1 by lens first time and mirror again coming back, so 1 by lens again. So 1 by infinity, this becomes equal to 2 by f lens plus 1 by infinity. The result is 1 by f silver lens is equals to 2 by fl, this value is fl. So 2 into 1 by fl, this becomes equal to 2 into 1 by fl. 1 by fl means mu minus 1. So the result is 2 into mu minus 1 by r. This behaves as a concave mirror. Our focal length is equals to same values. E is equals to f of concave mirrors. 1 by f you have taken, no? So 1 by f only taken is equals to reverse of this if you take focal length of concave mirror is equals to f concave mirror. E is equals to f of silver lens. This is equals to r by 2 times mu minus 1. So what is the radius of curvature of the concave mirror? If you take the concave mirror like this, radius of curvature is say r, that you need to find out radius of curvature of the concave mirror, and object is left side, image is also left side, image distance also left side, minus only you have to get the result. So that concave mirror formula only we can use for this problem also. These two types are there. Here directly focal length is given. Sometimes they will ask in terms of the radius of curvatures, then you have to use this formula and calculate the remaining part. But here directly focal length is given. So when they give the focal length, what to get the relationship is inter comparisons we need to take. This is the focal length of concave mirrors. Radius of curvature of concave mirror equal to 2 times the focal length. So we will get 2 times focal length of concave mirror, which is nothing but equal to r by mu minus 1. 2 cancels, you will get is r by 2 minus 1. Okay, this formula. But now coming back to this relationship, we need to take only the radius of curvature, not required to use, only focal length formula we have to use. So focal length of the silver lens compare with the concave lens. Concave mirror is equals to lens is given. So calculate this relationship we need to go for silver lens. Answer: silver plano-convex lens act as concave mirror. So focal length of concave mirror is equals to focal length of silver lens. What is the focal length of silver lens? Is focal length of silver lens is equals to 2 by focal length of the silver lens equal to 2 by focal length of the plano-convex lens, and 1 by f silver lens is equals to 2 by focal length of the lens. Focal length of the lens is 15 centimeters, which is 2 by 15. FL is 15 centimeters for plano-convex lens, not silver place, not silver, before silvering, not silver conditions. So FL becomes, this FSL becomes equal to 15 by 2, means 7.5. Therefore this part FCM equal to F silver lens is equals to 15 by 2 centimeter, that is 7.5 centimeters you will get. You are given now mirror formula you have to use for mirrors. For mirrors, 1 by f of the concave mirror is equals to 1 by u plus 1 by v. U is given as equals to minus 20 centimeters. Minus 20 centimeters. V equal to how much? Focal length of the concave mirror is, it's left side. Left side means it becomes equal to minus 15 by 2 centimeters, which is minus 7.5 centimeters. Substitute the values into this and find out the value of V. Therefore 1 by V is equals to 1 by F minus 1 by U, which is equals to 1 by F of concave mirror, 1 by 15 by 2, I am not taking 7.5, 15 by 2 minus 1 by minus 20, minus into minus is plus, so minus 2 by 15 plus 1 by 20. V equal to, you will get 12 centimeters minus, means left side. You check up the calculations, LCM you have to take, and it is 1 by V. Again you have to take the reverse of it. 300 kN LCM, and then check up that you will get this minus 12. To minus means what? Left side you are getting the image. So these are lens. Mirror behave like, that is the actual diagram, behave like a concave mirror. Focal length left side, radius of curvature left side, and U is here object falling, and the image is formed here. Focal length is also left side only, so we take it as a minus focal length. F is equal to negative, which is equals to focal length of silver lens, negative of focal length of silver lens. In case if they give the curved surface silver, they may give in reverse. Curved surface silver, that also acts as a concave mirror only, procedure is similar almost after this. But if they give the value like this, this formula will be different. If we give the curved surface is silver, then this R1 becomes equal to infinity. R2 is equals to R only we have to use. Left side it is, so negative it becomes, one thing. Second thing is, this is silvered. When it is silvered, now concave mirror focal length you have taken as equals to infinity here. Lens focal length of the mirror is infinity you have taken. But here it's not infinity. Focal length of the mirror becomes is equals to this radius of curvature times 2, by 2. Focal length of the mirror becomes equal to radius of curvature by 2 we have to take for these conditions, and the formula will be different. That is there in the theory concepts, please check up that. Mostly they don't ask that curved surface silver, they will be asking you plane surface silver only most of the cases. They may ask this part, this extra part I explained, they may ask in terms of this radius of curvature also. That problem is next, it is there. question, the plane surface of the plano-convex lens is silvered. 53, question number 53, plane surface of plano-convex lens is silvered. Mu is the reference index of the index, and R is radius of curvature of the curved surface. So small r is given as the radius of curvature of the curved surface. This small r is given, and they asked you what is the concave mirror radius of curvature concave mirror they asked. So this becomes equal to small r by mu minus 1. The capital R replaced with the small r. That is question number, this part is for question number 53. Let me check up that. Next question is, two similar plano-convex lenses are combined together through different ways. What is the ratio of the focal length? If you cut the lens, what happens? Cutting of the lens first, let us check up. Cutting of the lens, if you have taken the lens like this. Okay, you can cut parallel to the principal axis, any pieces, any number of pieces you can cut like this. So if you are cutting like this, what happens to the focal length? What is the focal length? Depends on 1 by f is equals to mu minus 1 or n minus 1 into 1 by r1 minus 1 by r2 is the basic formula for from the lens maker's formula. This mu is of this material surrounding is air we have taken. So by air, mu air you have to take, or n given means n you use that for the refractive index. But if I am cutting along this path, along the parallel to the principal axis, if I cut parallel to the principal axis, the radius of curvature r1, r2 remains constant, mu also remains constant. Then there is no change in the focal length. So if you cut along the principal axis, f is constant in this case. So how many pieces ever you cut? This small piece also will have the same focal length. This one also has the same focal length. This also has the same focal length. If you combine these two, one after the other, light ray falling is like principal axis, bends, deviates like this. If I keep one more here, convex, converging, again converging. So instead of falling here, that will be, if it is focused here by the first lens, this one again converges, it will be focused here. So instead of focusing here, it will be focusing, it again converges back, down. So focal length decreases if you take the convex and concave. So focal length is same place. This is also f and f same conditions. But same lenses if you keep in reverse, careful with that, this will be asked in the competitive exams many times. If you put in reverse, what happens? If you put in reverse, this one is bending light ray down, this one is bending light ray up. The result is no deviation. It just acts like a plain glass slab. This focal length is down, it is reversing it towards the principal axis, away from the principal axis. The result is whatever is coming on, that same thing. It's supposed to focus here, but it will be like this, coming like this, and there is no deviation. I am telling here without gap actually. Thin lenses without gap. If gap is there, then there is a possibility of the focal length, having focal length. That formula combination you have to take 1 by f equal to 1 by f 1 plus 1 by f2 minus d by f1 f2 formula to calculate the resultant focal length. But the same focal length means 1 by f plus 1 by f 2 by f minus d by f square is equals to 1 by f prime, reciprocal formula. This behaves like a plain glass slab. But if I cut the same lens vertically, what happens? Perpendicular to the principal axis, if I cut like this, then this becomes equal to f1 and f2 symmetrically. So same radius of curvature, this and this, and each one behaves as a plano-convex lens separately. This focal length, radius of curvature is r1, this is also r2, but for each lens this becomes equal to r2 prime is infinity. For this r1 prime is infinity. So plano-convex lens you will get. Plano-convex lens if you have taken means whatever the focal length is, each focal length becomes equal to this each one. f1 is equals to f2 is equals to 2 times the focal length. Focal length increases because other radius of curvature it becomes equal to infinity. So if you combine these two, you may get this combination. So combination of these two becomes equal to 1 by this half equal to 1. Another thing is you can take like this combination. You are told here in this question two similar plano-convex lenses are taken. They combine in the different ways. Thin, not thick ones. They cut like this, touching place, contact, and also kept both sides. This is f, means this each one becomes equal to 2f. If you combine these two, what happens is 2f, d is 0. So the result becomes equal to this f. The result of this combination is also f. This is the result of this also combination of f. By this method, d is 0. You have to take. So you combine like this, or like this. The focal length is same. It means you can keep the radius left side, right side. The focal length do not change for a paraxial rays. Next 42 also plane surface silvered, similar problem, please check up that. 51, 51 just now I discussed. 52 plane surface silvered, 53 also plane surface silvered, and 54 lens immersed in the liquids, that you can work out. Next problems, prisms, combination of the prisms, that is not there for a case set, but I will discuss that later. Next 57 question we have to discuss. Thin prisms I have to discuss in the next class, and dispersion related to that. The silvering may be given double convex, concave, convex, all the hints are given in that notes. Just check up that. Mostly they don't ask, but JEE mains and advanced it's possible to ask. For a convex, double convex silvering also, concave silvering till now not asked but can be asked. It is easy to find out. Just combination of the lenses and mirrors you need to take. That is there in the synopsis, you can go through. 57. Refractive index of the lens of the metal is mu and focal length is f. Mu is equals to refractive index, f is focal length. Due to some chemical changes, the refractive index increases by 2%. Chemical changes or temperature changes, refractive index increased. So in this mu is the refractive index, f is the focal length given, and due to chemical changes, due to some chemical reasons or due to the temperature changes, refractive index increased by 2%. Be careful with this term. Increased means plus you have to take, decreased means minus you have to take. And here change is given very small values, less than 5, like 2, 3, 4, like that given means you take the approximated formula of the calculation of the percentage errors. Due to chemical changes, the refractive index increased by 2%. Mu is 1.5 for the material. Find the refractive index, find the change in the focal length. Percentage change in the focal length you have to find out. Lensmaker's formula focal length what we have is 1 by f equal to mu minus 1. You can take n minus 1, that is left to your choice. 1 by r1 minus 1 by r2. Whether it is a concave or convex, these modifications we can do later, but it's not required here because r1, r2 are constants. r1, r2 are constant. Constant means there is no change. So when you are talking about the percentage changes, no, constant terms don't take. Mu is changing, focal length changing, but 1 by f means take it to numerator, it becomes equal to f to the power of minus 1. Mu minus 1 into 1 by r1 minus 1 by r2. Percentage in the refractive index is given for us, increased by 2%. So mu, delta mu by mu, initial values, change in values by initial value into 100% actually, directly I am writing percentage equal to plus 2%. Plus 2 means what is increase. Next, if I are asked to find a percentage in the focal length is how much? Delta f by f percentage equal to how much? Take the error formulas, calculation methods. Power comes as a multiplication. Delta f minus into delta f by f. Change in focal length by initial focal length is equal to delta mu by mu, remaining constants. One is also constant, don't consider it. So delta f by f is equals to delta mu by mu. But minus power is there? No, minus comes as multiplication. But errors purpose we take always positive, but here we minus means minus, plus means plus. Plus means increasing, minus means decreasing. So delta f by f becomes equal to minus, go to the right side. Delta f by f percentage equal to minus of delta mu by mu percentage. But delta mu by mu you are given as a 2%. 2% increased. But because it's minus, it becomes equal to minus into plus is minus only. Minus means what? Decreases. If mu increases, focal length decreases, reverse relation. So focal length decrease by 2%. This is for small changes only. If they give radius of curvature changes also, we have to take delta r by r minus, of course, this is also minus of, don't consider this. Convex means it becomes equal to, again, double convex means minus of minus plus only becomes. So delta r by r, delta r2 by r, delta r1 by r percentages only we need to consider, but generally they don't ask you that question.